Here's a problem that looks trivial and is genuinely hard. When an order is submitted, two things must happen. You save it to your database, and you tell the outside world so the payment can be charged. Save and publish. Easy, until you ask, what if the process crashes right in between? You've saved the order but never published, so the payment never happens. Or you published, then the save rolled back, so you're charging for an order that doesn't exist. You can't wrap a database and a message broker in one transaction. This is the dual write problem, and the Outbox is the answer. Let's be precise about why it's hard. Your handler does two writes to two different systems. It commits a transaction to your database, and it publishes a message to a broker like a queue or a bus. There is no transaction that spans both. So there's always a window. If the machine dies after the database commit but before the publish, the order exists and no one is ever told. If it dies after the publish but before the commit, the world hears about an order that got rolled back. And the classic textbook fix, a distributed two-phase commit across the database and the broker, is so brittle and so bad for availability that essentially nobody runs it in anger. We need the guarantee without the distributed transaction. The insight is simple and a little bit clever. Stop trying to publish to the broker inside your handler. Instead, in the very same database transaction that saves the order, insert a row into an Outbox table describing the event. Now there is only one commit to one system, your database, and it's atomic. Either the order and its Outbox row are both saved, or neither is. There's no gap anymore. Then a separate background process, the relay, wakes up, reads the Outbox rows that haven't been sent, publishes them to the broker, and marks them done. If it crashes after publishing but before marking, it'll resend on the next pass, so delivery is at least once. You've turned an impossible atomic dual write into an ordinary atomic single write, plus a retrying relay. At least once has a consequence. The consumer will, occasionally, receive the same event twice. So the receiving side needs its own guard, the inbox. Before handling a message, the consumer checks an inbox table of IDs it has already processed. If this event's ID is there, it's a redelivery, and it's skipped. And the ID isn't random. It's derived deterministically from the business fact. So the same logical event always carries the same ID, even if it was translated and resent. At least once delivery, plus inbox deduplication, plus handlers that are safe to rerun, gives you an exactly once effect. Our whole payment round trip rides on this. Submitting an order publishes OrderSubmitted through the Outbox. An external payment service charges the customer and sends back PaymentConfirmed. Our inbox consumes that idempotently, and recording the payment is exactly what unblocks approval. Two services, a broker between them, and not a single lost or double-counted event. Here's the Outbox side reel. First, a translator. An ordinary domain event handler that turns the internal OrderSubmitted event into a primitives-only, versioned integration event, just IDs, the total, a currency, a timestamp, so external consumers never depend on our internal types. Notice the deterministic event ID, derived from the order ID and the word submitted. That's the deduplication key, stable across any redelivery. Then the wiring, 3 calls. An interceptor that captures the event into the Outbox table as part of the transaction, the table mapping, and the relay as a background service. That's it. The event is now written in the same atomic commit as the order, and the relay ships it after. No inline publish, no gap. And here's the receiving side, and this is where a toy demo and a real service diverge. The inbox handler doesn't just record the payment, it interrogates it. Wrong currency? Log it and acknowledge. Don't reprocess forever. Unknown order? Log and move on. Order isn't in submitted status. Maybe it was canceled? Then a payment must never quietly mark it paid. Log and ignore. Amount doesn't match the order total? That's a business fault, not a payment. Reject it. Only a submitted, unpaid order whose amount matches actually records the payment. And record payment is itself idempotent. So a redelivery that slips past the inbox's own deduplication still counts once. 2 calls wire it. Register the inbox with a consumer ID and register the handler. The framework gives you the dedupt table and the exactly once effect. You decide, explicitly, what a valid payment even is. So the dual write problem has a clean answer, and it isn't a distributed transaction. Write the event into an outbox in the same commit as your state, one atomic write. Let a relay publish it at least once. Guard the consumer with an inbox so redeliveries collapse to a single effect. And make the handler strict about what it accepts, logging every rejection instead of looping on a poison message. That's a payment round trip you can trust across a network that drops and duplicates messages. We've now built the whole service: write, read, auth, eventing. Next episode, the tests that prove every claim we've made. Subscribe, and I'll see you in episode 7.